continue to extract what we call ecosystem services from the environment.
Yeah.
We get clean air, we get food, we get all these raw materials for building everything that's around us. We want to keep getting those ecosystem services, but that needs to be sustainable.
Hi everyone, and welcome to Mug of Science, a Pint of Science initiative where we chat to local scientists over a morning cuppa. Today we're at the Ourimbah campus at the University of Newcastle. Unfortunately, it was raining outside, so we had to relocate into the lab, but we're making the best of it. We're in the beautiful Marine Science Lab at the Ourimbah campus. And I'm lucky enough to be joined today by our Associate Professor Troy Gaston from the Department of Marine Science. And we are going to be talking about all things
Coastal.
all things coastal. Thanks for coming. We start every interview with the same question, and that question is, what is in your mug?
No mug.
No mug?
It's water.
Yep.
But we're in a lab.
It's true.
No drinking.
Yes.
And I notice your mug's empty.
We are following occupational health and safety procedures,
Absolutely.
so we are not allowed any liquid.
No liquid.
No liquid. Also, we've got a little friend here. Would you like to introduce your friend?
Yeah, this is Jasmine.
This is Jasmine.
From the movie Aladdin. We have Jasmine, Aladdin and Genie now. This is an ROV, remotely operated vehicle.
Yeah.
Scuba diving, bit of an OH&S issue because you're in a non-breathable environment. But we can take Jasmine here to 100 metres depth, not a problem.
Yeah.
She provides a live feed to the surface with the camera here. We've got the lights. And this particular ROV, you can move in any plane and direction, and it has fantastic stability. And if anything goes wrong, it's on a tether, you can just bring it back to the surface.
Great.
We've even got an arm we can put on it for grabbing samples as well. But it allows us to also do a lot of mapping.
Yeah.
Underwater video and mapping, one of the first things we need to know is what do we have in the marine environment?
Yeah.
Little Jasmine here is our first step in collecting all that data.
Yeah, I can imagine it increases the access you have to those local environments.
Absolutely, and if you are good with a PlayStation, you'd be good at driving Jasmine. I am not, so I'm not allowed to drive Jasmine.
You don't have your Jasmine license?
I do not have my Jasmine license. I'd probably crash her into something. So I'm not, this is for the young kids.
Yeah. Why don't you tell us a little bit about yourself? Tell us about who you are as a person and kind of what brought you into science and where you are now.
I come from a family of scientists. So I was pretty much just bred to be another scientist. My brothers are engineers and scientists, computer scientists. One of them's a rocket scientist. But I had a love for the ocean as a kid. My parents struggled to keep me out of the water, especially the beach. And I love science. So I just combined the two, and marine science was just a great fit. And I really picked up on that because I loved fishing with my grandfather, and my dad taught me how to scuba dive, or snorkel and then scuba dive. So it was all just starting to make sense. And when I was scuba diving, I would just sit on the bottom, blowing bubbles. Why is that fish doing that? What's going on with that reef over there? I just wanted to know how things work in the ocean.
You just had that scientific curiosity.
Yeah. It might start with just building Lego.
Yeah.
How can I put these different things together?
I think that's really interesting. I think that's a common pathway for a lot of scientists, just as a kid trying to figure out how the world around you works. And obviously yours was located in the ocean.
Oh, absolutely. My grandparents lived on the waterfront, so that was great. Every Christmas holiday was down the south coast of New South Wales at the beach or in the estuary. Yeah. So I was always around the ocean. It was, salt water in my veins.
Yeah. And that obviously put you on the path towards becoming a marine scientist, marine biologist. I don't know if there is a distinction. I'm not up to...
There is actually a distinction. So marine biologist is just the plants and animals. And I guess marine scientist sits above that. And it's, it might be marine chemistry, it might be how the oceans and currents work and tides. It might be how sediments move. So they're all components of marine science. A marine biologist, well, they focus on the biology.
Sure.
I guess I'd almost be classified as a marine ecologist, which is how animals, plants, the ecosystem, the habitats, the water column, the sediments, how everything interacts and works.
Yeah. The full ecosystem.
The full ecosystem.
Yeah.
Absolutely.
Awesome. So tell us a little bit about how you got started, I guess, in, like, say you had an initial love for the ocean, trying to figure it all out. I guess at some point you started university and you went through your PhD. So tell us a little bit about that.
Yep. I loved science at school. Yep. So I was one of those weird kids that actually loved chemistry and biology.
I think we all
okay,
were.
Yeah. I'm pretty sure everyone listening to this has probably loved science. Yeah. At the end of high school, I still wanted to go and do more. I just wanted to learn more, and it was focused around science. So I just thought, well, I love the ocean. Can I bring the two together? And that was quite obvious that marine science was going to be an option for me. There's actually not a lot of places in Australia that explicitly study marine science. So I went off to uni, absolutely loved it. Worked out during my undergrad, I really want to focus on coastal ecosystems where we live.
Yeah.
So in Australia, it's now over 80% of our population live within a 50-kilometre stretch, or within 50 kilometres of the coastline. That's intense from our perspective, but when you look at places like Hong Kong, that's just insane. New York, that's just insane how many people are living in that coastal zone. So we're obviously going to have some effects.
Sure, yeah.
What are they? Can we mitigate? Can we adapt to what's happening in the oceans? Whether you believe in climate change or not, the oceans are rising. They always have. They will again, but they're rising a whole lot faster than they ever have before, and that's an issue for us. How do we adapt to that? Mitigation it's quite difficult because there's a political will behind the mitigation, but adaptation. So how are humans interacting with the coastal environment? What effects are we having? We can have both positive and negative. My PhD was around sewage effluent. That was a very obvious negative effect. We have to discharge it somewhere.
Yeah.
But is there a positive effect of putting sewage effluent into the ocean? You break it down, it's fertiliser.
It's fuel, yeah.
It's fuel for the ocean.
Yeah.
It's carbon, it's nitrogen. They're two of the most important nutrients that the ocean needs to grow.
So is it a matter of dosage or kind of rates of release?
It's a bit of both.
Yeah.
Our oceans around Australia are actually nutrient poor just because of where we sit in the South Pacific and with the Indian Ocean. So we're actually fertilising our coastal oceans. And if we do it, our coastal seas, if we can do it in such a way that there'll be no adverse negative effects. Same as we fertilise our lawns, our gardens, if you do it at the right time, when everything wants to grow. And we also look at how we're, applying that fertiliser, then we can have a positive effect on our coastal seas. And I actually found in my PhD that a lot of the tissues, the proteins, amino acids in fish originated from human sewage.
Okay.
But those fish are perfectly fine to eat.
Sure.
So the nutrients have just made their way up the food chain into the species we like to eat.
Okay. So it's almost
there's a full circle of life going on here, which some people might go, oh, I'm not going to catch and eat anything off Sydney. But there's no metals, there's no bacteria in those fish. They're perfectly fine to eat. It's just where did that carbon and nitrogen come from that supports that food web?
Yeah, that's the circle of life, isn't it?
Absolutely. I'm pretty sure there's a movie about that.
Yeah, I think so. A couple of years ago. Yeah. Cool. I mean, that sounds great. What were you going to say?
So that's the first thing I got into, and it just led me on to, okay, how else are we actually having an effect, positive or negative, on our ecosystems? And one of my main areas of research now is, can we repair our ecosystems? The UN, so the United Nations, have declared an international decade of ecosystem restoration, and that's a global initiative. It's both aquatic and terrestrial, just because of degradation of our systems. Now, Australia, yes, we've had degradation of our ecosystems, not to the extent of other continents, but certainly enough that we've seen negative effects from the environment. One that resonated with me and would resonate with a third of Australians is the ability to go and do some recreational fishing. It's a huge industry. A third of Australians do it every year. We always wanted to catch fish. In my lifetime, I've noticed there's just not as many fish. That's not because I suck at fishing. Maybe I do, but people have, back in my day, I used to catch all these fish. Everyone's heard those stories. You used to catch fish this big.
2-foot barra.
Yeah. When they do that, just look where their thumbs are, because that's the actual size of the fish,
Okay.
not where their index fingers are.
Insider tip.
A hot
Yeah.
tip. That's what they do. So how can we get some of that productivity back?
Yeah.
So a lot of our work is around, and a lot of my interest is around ecosystem or habitat repair. Restoration implies we'll get it back to what it was before humans started to have an effect, which would be really difficult.
Yeah.
Have a look at the amount of land clearing, the amount of dredging, the amount of coral reef destruction, just so we get access to coral islands and whatnot. Okay, so rehabilitation is some sort of improvement. Okay, that we can do.
Yeah.
It could be a 5% improvement, a 10, 20, 30. Same as similar to the CO2 emission targets. How much of a reduction do we want?
Okay.
We can be aspirational, or can it be achievable? So I look at that from an ecosystem perspective. What could we achieve in repairing our systems?
So when you say a 5 or 10% improvement, what are we actually looking at? What are we measuring or trying to quantify at that point?
So there's a few different things you could actually refer to when we want some improvement.
Yeah.
So is it 5% improvement in water quality? So we want the water to be clearer. 20% reduction in nutrients. Yep, we could do that. Do we actually want an increase in fishing output? So how do we actually maybe increase fish biomass or fish abundance? So there's a few different things we could actually ask in that regards.
Yeah. Okay.
And I love recreational fishing.
Yeah.
Heaps of Australians do. So can we get fish for the future, which is a catchphrase that a lot of government entities use.
Yeah. And you work locally with a lot of local community groups and government agencies as well?
Oh, absolutely.
Yeah.
Local councils,
Yeah.
they get banged on the head a lot
Yeah.
for either not doing something or doing something wrong, but they're quite often the link between the general community and what's actually going on in the environment. And they actually do lots of good work.
Yeah, and they're very supportive.
They are
Yeah.
very supportive of the research, because they understand that science-based policies, science-based management, science-based decisions is where we have to go.
Yeah.
Where's that empirical evidence that's been collected in a scientific manner, so it's robust, defensible?
Yeah.
This is going to be your best way forward.
So how far do you think along the path of us having this, relationship with local government agencies to drive policy, are we in an initiation phase, or do you think we're pretty well down the track that we can maybe start to see some, more systemic change or benefits coming?
We're definitely not at the beginning.
Yeah.
We've got pretty much all the coastal councils in New South Wales are very proactive about protecting the asset.
Yeah.
And our ecosystems are an asset. Everything we do in society, economics, productivity, you don't have a functioning ecosystem or environment, you're not going to be able to do any of that.
Yeah.
And there might be a lag effect because the ecosystem takes a while to respond, but eventually you screw up the environment,
Yeah.
you're not going to be able to do anything.
Yeah.
Councils realise that. So we've got a lot of great support, and just the way we do ecosystem management in New South Wales, there needs to be some science underpinning, all right, this is what we're going to target next. We don't know how that works, or how do we focus our efforts to fix that problem? So there's a couple of ways we can approach the problem, all scientific approaches of how do we fix that, or how does that work? How do we change that? Why did that do that? And we've been working with councils, state government, even not-for-profit organisations, such as Ozfish, which it supports the recreational fishing industry. They want to know, A, how can our members help you as scientists, so citizen science, but also what information do you need so you understand how the ecosystem functions, so we can have a better recreational fishing resource. So pretty much everyone's on board.
Yeah.
So we're actually along that timeline further than a lot of people would think.
Yeah.
And we're beginning to now understand, you want to fix this habitat or you want to fix this waterway, here's one place you could target and get a good bang for your buck straight away.
Okay, cool. Could you give me maybe an example of one of those initiatives that you have kind of happening with some local partners, and then maybe are there like one or two things that myself or anyone as an individual, like what we can do to maybe have a beneficial impact on our local environment?
I always get asked those questions.
Yeah.
So what is it I can do?
Yeah.
Well, you can always go to uni, become a scientist and get on board.
Yeah.
That's one thing. But A good example, a lot of our estuaries, in New South Wales, we've lost nearly 70% of fish habitat. And that's directly from human activities.
Yeah. So
Some of those activities which are land-based and higher in the catchment are not likely to go away. We can do them a bit better. But how do we get those habitats back, which will then flow on to just fishery productivity, fish biomass? Because there are two things lacking in aquatic environments: food and habitat. And things like seagrass, mangroves, salt marsh, which we call habitats, are also food. We understand, and a lot of recreational fishers know, where certain species of fish hang out. Are they in the seagrass? Do they like to be near the mangroves? Are they just hanging on the sandbank, like flathead like to do? Once we know, so we know that, where they like to be, what are they eating?
Yeah.
So food could be limiting. So which of those habitats is most important for food? And we've been working with council, local council, state government and the not-for-profit organisations in a couple of different estuaries. Okay, which habitat's most important? And we've actually identified it as to being salt marsh, which is that low-lying plant that is highest on the intertidal. It's closest to where we live.
Yeah. It's the first thing to go when we expand.
It's the first thing to go with coastal urbanisation or any form of urbanisation.
Yeah.
And it's called coastal squeeze. So here's the fence.
Yep.
Here's the salt marsh.
Yep.
As the sea level rises, salt marsh has got to keep moving up the shore. It can't. There's a fence. We built there, or we put a rock wall, or there's a park, or something else going on. So that habitat is actually squeezed out of existence. So we're working with coastal engineers about identifying where in the catchment, and they're also called eco-engineers and eco-hydrodynamics. So where does the water go? Where is it likely to go?
Yeah.
Where in an estuary or a catchment could the council or state government buy back land and allow these habitats to actually return and move up the shore with rising sea levels?
So that seems to be the solution. Just it needs the land. There's no way around it.
Absolutely.
Yeah.
Or the other option is retreat. Get those people to sell up their houses and move somewhere else.
Okay.
Good luck with that one. Let's move that park. Let's move that shopping centre. Let's move that car park.
Yeah.
Possibly not going to happen. So it's a balance.
Yeah. I mean, it's interesting because you always hear about community initiatives to build walking paths, along nice bits of waterways because it's, it promotes activity and all these other social benefits, but you never think about, well, what are the actual ramifications of that on the ecosystem? We tend to think only of ourselves, I guess.
Oh, we're always thinking, what's the socio-economic benefit, or typically the economic benefit. I love footpaths and boardwalks near waterways because people get to see what it is we're trying to protect.
You get an
and we can
appreciation.
actually build them in a way that can actually provide a positive outcome. And as an example, we did some work looking at private jetties in Lake Macquarie.
Okay.
And it provides additional habitat that wasn't normally there. It's like having a reef in the seagrass. Now we can build the jetty out of materials so it allows enough light through, doesn't damage the seagrass. You're now providing additional structures which things grow to and brings in other species of fish because they like to hide around the structure. So it's basically a fish aggregation device or a fish attracting device.
Yeah.
The island nations have been using them for 60,000 years. Throw a few palm fronds in the ocean, fish will come to it.
Yeah. It creates an artificial reef or...
Yeah, it's an artificial habitat.
Yeah, yeah.
So we can actually put coastal structures in that have a positive benefit.
Okay.
We just need to do more of it.
And that obviously starts at a government policy level in terms of what actually gets built on our coastal ways.
Well, we could actually go back one step and say it starts with the science.
Yeah.
What sort of effect is this going to have on the environment?
Sure.
And then we pass that data on to the government.
Yeah.
Okay, is this within your planning laws? Yep, you can do it.
Okay.
So we've provided that feedback to Lake Macquarie City Council, and they can, all right, is it the number of jetties that might actually have an impact on the environment, not just a single jetty? So that's the next stage of the research, the next stage of the science.
Yeah.
How much is too much?
Yeah. That's really interesting. I think it's a perspective that I would never have, come to myself, particularly appreciating the waterways and what goes into understanding, and then hopefully trying to create infrastructure essentially to make sure that we keep it into the future. Yeah. Absolutely.
Most of our science, but actually all of our science, is applied.
Yeah.
How is yes, how is it going to benefit humans? But it still has the crux of it. The environment has to not be affected here.
Yeah. Well, it's symbiotic, right? Because we need the environment. And
That's a really good way to
we
describe
impart an influence on the environment, so it's a.
Yep. Well, we're going to continue to extract what we call ecosystem services from the environment.
Yeah.
We get clean air, we get food, we get all these raw materials for building everything that's around us. We want to keep getting those ecosystem services, but that needs to be sustainable.
Yeah. That's great. Yeah, we are part of the ecosystem.
Absolutely. Absolutely.
All right, Troy. Well, thanks so much for your time today.
Yep.
I guess we try to wrap up every episode by asking the same question. For you, and the question is, for you, a scientist is someone who
loves to know how things work.
Yeah.
And you approach that problem in what we would call the scientific method, and it's just the scientific method's a process of how you tackle a problem.
Yeah.
How do you figure out?
It's that curiosity.
It is curiosity, and how do you figure out how something works?
Yeah.
It's
Great.
the best.
Yeah. Well, thanks so much for your time. If anyone wants to get in touch with you or in contact, is there a preferred way to reach out to you?
If they jump on the Uni of Newcastle website and just type in my name, the profile's there, the work we're doing, and there's a range of contact details there if they've got any further questions.
Yeah. Great. Well, thanks so
Awesome.
much. Thanks for your time.
Thanks,
I
Nadai.
hope you enjoyed it.
Always love talking about science.
All right. Thanks everyone for watching. We'll see you in the next one.